Hi, everyone. As Michelle said, I'm Katherine, and I'm going to be discussing today designing devices for collection of PFAS from atmospheric deposition. So we'll continue on with the PFAS theme. I think Celia did a great job just describing PFAS, so I will hold off on any further explanation, but I'd love to go into a little bit of atmospheric deposition. So PFAS end up in atmospheric deposition, or PFAS end up in the atmosphere generally as a result of emissions from industrial and manufacturing processes. And then once suspended in the air, PFAS can be subject to short and long range transport, usually through wind or through atmospheric currents. Then for these to come out of suspension, this usually happens through wet deposition, so through precipitation like snow or rain, or dry deposition, which would just be, in this case, the settling of particulates. What we're concerned with here with our sampling is bulk deposition, which is the combination of these two together. And why we're concerned about this is partially for the ecological reasons, as well as the impacts on drinking water. PFAS, when it's atmospherically deposited, ends up in our surface and groundwater bodies, and this can pose a significant threat to ecology as well as to human drinking water supplies. So our samplers are located at 4 different sites. We have one at Adams Point, one in downtown Dover, and 2 at 2 of the UNH research farms. And this kind of gives us some different land use settings to be investigating. Additionally, we have a paired wet and bulk deposition sampler that we're using at Thompson Farm, so we can compare the wet only versus bulk deposition there. In terms of sampler design, we started with an original design, which I have pictured at the top, and then refined that to create the final design seen below. With our original design, we had some algal growth that was happening in the bottle. So we switched this to HDPE darker bottles so that they would have less light penetration and then thus less algal growth. Additionally, we were getting some bird droppings, bugs, larger particulates in our samplers. So we were decided to sample more frequently, as well as cleaning when there were periods of time where we weren't experiencing a lot of precipitation. Additionally, the ability to collect sufficient sample volumes was kind of an issue with the original sampler, just because the bottle, sometimes in an individual storm event, we wouldn't be able to collect as much precipitation as we need to run the analyses necessary to look for PFAS. So by doubling the bottles, we'd collect twice the volume, which we could pull together into one sample. Finally, funnel stability was also an issue. You might be able to see in that top photo, we have a metal bracket that's supposed to be holding the lip of the funnel down, but sometimes this bracket or the funnel would pop out from under the bracket. So to address this, I created an integrated funnel bottle cap. So the funnel is part of the bottle cap that just screws off for easy sample collection, and then it can be cleaned and replaced. However, now with all the snow we've just gotten, there's some additional design considerations that we need to make some modifications for. We need a greater volume of snow to collect samples just because it's going to melt down into a smaller volume liquid. And additionally, as the funnel setup currently is, snow buildup in the funnel would prevent additional volume from funneling down into the bottle. So some potential solutions here are the addition of a heating element to melt the snow on contact so it can just flow right into the bottle. However, there's some potential issues with power supply here just due to the nature of where some of these sites are located. Another potential option is collection into some large open top containers that then can be melted in the lab later on. This is something that we're still working on in our lab, so if anyone has any ideas, I'd love to talk with you later. Finally, I'd just like to get into some preliminary data just so you can get a hint of what we're seeing so far. So we've collected a total of 47 samples and detected 20 different PFAS across those samples. In looking at some of the regulated compounds, PFOA and PFOS here, we didn't detect any statistically significant difference in concentrations of these compounds across our different sites in the Great Bay watershed. But looking globally, we've seen some differences. For example, in the Great Bay, the concentrations we're seeing in precipitation of these compounds are similar to what's being seen in the Great Lakes, but it's much lower, for example, than what's seen in urban China. And with that, I'd like to thank you for your attention. And I'd also like to thank the Ag Station Create Program and PrEP for helping fund this research, as well as New Hampshire Sea Grant for supporting it in graduate fellowships.